Now let's review vectors. So if it's been a while, let's just remind ourselves what vectors are. Let's see, let's think about this. I'm driving on the road. I'm driving down the road and I'm following the speed limit, which is 65 miles per hour. I'm happy with that. This thing here, this just gives me a rate. So this just tells me that I am going some certain speed. In the wrong units for this class, but I'm going some certain speed. So what we call this thing is a scalar. A scalar has just a magnitude. It just gives us a valued quantity. If I wanted to turn this into a vector, now what I'm going to do is write it in the correct units. So we get in the habit of seeing that. And let's go with our last result was 26.8 meters per second. And now a lot of folks will look at this and they'll say, well, that's a vector because it's velocity. It isn't a vector yet until I add direction. So what I can say, so this is 26.8 meters per second in the x direction, where this denotes that it is a vector quantity. So this is a vector. This is a vector. So the difference between the two then is a scalar has magnitude only, just magnitude. And a vector has magnitude, I'm going to shorten that as mag, and direction. And direction. So that is the vector thing that we are going to be working with. And there's a couple of things that we can talk about here. Is that everything we're going to do is adding vectors component-wise. I don't know of another way to add them, but they have to have the same thing. If you think about it in terms of, if I give you a generic equation that was like 3x plus 4y equals, I don't know, 2. Why not? If I gave you that, most of you instinctively would look at this and say, well, I can't add the x and the y. They're two different variables. Well, I can turn this thing into a vector equation. I can say 3, whatever unit I have in the x plus 4 in the y. Well, now what this thing is saying is that I can define the behavior of this system. This is just a coordinate point. So now I can go ahead and draw it out all pretty like. Let's give this 1, 2, 3, 4. 1, 2, 3, 4. And so what this is saying is this vector lives over here, over 3 in the x, and then up 4 in the y. And now I can make that thing a real pretty vector. Not with that color. Let's go with black. Goes like that. So just coordinates, that's it. This tells me how far over in the x, how far up in the y, and that could be down, it could be in the positive x, it could be in the negative x, it could be a positive y. Let's go ahead and label these axes anywhere. But that's all a vector tells us. So I'm going to stop there, and then we're going to do some math with this.